In this section, we will continue to talk about derivatives. So just as a quick recap from the last section, the derivative is the slope of the tangent line at the point x comma f of x, right? We learned that last time. We also learned that to find this, we needed to take the limit as h approaches 0 of f of x plus h minus f of x all over h. But we saw that using this method, it took a long time. So in section 1.5, we're going to learn some theorems and formulas to make this process a lot easier and a lot faster. First, let's talk about some notation. The derivative f prime of x can be also referred to as dy dx, which is read as the derivative of y with respect to x. It can also be written as ddx f of x. So for a quick recap, f prime of x or dy dx or ddx of f of x. This is all notation for the derivative, which is the slope of the tangent line at the point x comma f of x. So if you have a curve and pick a point, then the slope of that tangent line, that will be the derivative at x equals to whatever x comma f of x is. So here's our first theorem called the power rule. For any real number k, the derivative of x to the k power is equal to k times x to the k minus 1. So this basically means that if you want to take the derivative of, let's say, x to the fourth, the rule is that the exponent comes to the front, so the 4 will come to the front, and then we subtract 1 from the exponent. So this actually gives us 4x to the third power. So the derivative of x to the fourth is equal to 4x cubed. Here are some important tips. Always write variables on the numerator using negative exponents. So if a variable is on the denominator, we always want to have it on the numerator. So 3 over x to the fourth, in order to move the x to the fourth to the numerator, it will become 3x to the negative fourth. We want it to be in this form where we can apply the power rule for derivatives. Write variables using rational exponents if in radical form. So if we have the cube root of x to the fourth, this will equal to x to the 3/4. Okay, so these two are going to be very important rules. Any radical exponent needs to be in rational exponent form, and anytime you have a variable on the denominator, move it to the numerator and make it negative if necessary. The third rule, when write the final answer using only positive exponents, which is true, and then it doesn't actually need to be in radical form for this class. In my open math and on the exams, you can leave it in the form of a rational exponent like x to the 3/4. Okay, so let's do some examples. If f of x equals to x to the fifth, find f prime of x. Okay, so f prime of x, we take our exponent 5 and we move it to the front, and then we subtract 1 from the original exponent. So this will give us 5x to the fourth power. Next, if g of x equals to 1 over x to the ninth, find g prime of x. Now remember, our variable always needs to be on the numerator to begin with, so we're going to rewrite g of x. If we move the x to the ninth to the numerator, then we have to change the sign from a positive to a negative. Anytime we switch from denominator to numerator or vice versa, we have to change the sign of the exponent. So when it goes to the numerator, it becomes x to the negative ninth. Now the derivative of that, the negative 9 is going to come to the front, and then we take negative 9 and we subtract 1 from it. We always subtract 1 from the original exponent. Negative 9 minus 1 is negative 10. So this gives us negative 9x to the negative 10th. And we have to write our answer using only positive exponents. So this equals to negative 9 over x to the 10th. Here's another example. Let's say we have x to the negative 11th. Find h prime of x. So h prime of x, we take the exponent negative 11, move it to the front, and then we subtract 1 from the original exponent. So negative 11 minus 1, this will give us negative 11 x to the negative 12th, which is equal to negative 11 over x to the 12th. And again, for all of these, we are using the power rule, where the exponent comes to the front and we subtract 1 from the original exponent. If f of x equals to cube root of x squared. So first off, we need to rewrite f of x using a rational exponent, which is going to be x to the 2/3. The 2 becomes a numerator, 3 becomes the denominator of the rational exponent. For f prime of x, we take our exponent and move it to the front. So this becomes 2/3, and then we take our original exponent and subtract 1 from it. So this gives us 2/3 x to the 2/3 minus 3 over 3. Whenever we subtract exponents, or fractions rather, we need to get a common denominator. So this is like a 1 over 1. If you multiply it by 3, it becomes 3 over 3. So this gives us 2/3 x to the negative 1/3 power. We need to rewrite this using only positive exponents, so the x to the negative 1/3 is moved to the denominator. So the numerator, we have a 2. The denominator already had a 3. When the x to the negative moves to the denominator, the exponent becomes positive. So our final answer is going to be 2 divided by 3x to the 1/3 power. Finally, we have g of x equals x to the 0.4, and we want to find g prime of x. Okay, so g prime of x, we move the 0.4 to the front. We take the original exponent, subtract 1. This gives us 0.4 x to the negative 0.6, which is going to be 0.4 divided by x to the 0.6. It's a negative exponent, so it moves to the denominator and it becomes positive. Another theorem. The derivative of any constant function is 0. Okay, once again, the derivative of any constant function is equal to 0. So the reason for that is, let's say we have the line y equals 3. It's going to be a horizontal line. It's going to be like this. Now, if I take a point on that line and I try to find the tangent line, well, the tangent line is the line itself, and the slope of that is equal to 0. So the slope of any constant function is equal to 0. Now, if you have the derivative of a constant function, then that constant function can just be moved to the front. So this becomes c times d dx of f of x. I'll give you an example. Let's say we want to find the derivative of 5x to the 3rd power. So there are two ways we can think of it. One way is you can move the 5 outside. So the 5 just is going to be a separate thing. And then we have d dx of x cubed, which will be 5 times. To take the derivative of x cubed, the 3 goes to the front. And then we subtract 1 from the 3, so it becomes 3x squared. And then you multiply 5 and 3, and we get 15x squared. So that's one way to look at it. The other way to look at it is we can just take the 3 and multiply it with the 5, so that this will give you 15x to the 2nd power. And we'll talk more about that later on. Next, the derivative of a sum is just a sum of the derivatives. So if you have d dx of f of x plus g of x, we can separate this into the derivative of f of x plus the derivative of g of x. Same thing goes for subtraction. So here's some examples of that. If f of x equals to negative 8x to the 5th, f prime of x, we'll do it two different ways. The first way is kind of the longer way. The second way is a shorter way, which is the one that we are going to be using in class. But I want you guys to see where the shorter way is coming from. So I'm going to rewrite this f prime of x as negative 8 d dx of x to the 5th. Remember, when you have a constant, that constant comes outside. So now, the derivative of x to the 5th, the 5 is going to come to the front, so it'll be 5, and you subtract 1 from it, x to the 4th. Then if you multiply negative 8 times 5, this gives you negative 40x to the 4th. The second way, the shorter way, if you want to find f prime of x, remember our original function is this. It's equal to negative 8x to the fifth. So the 5, it multiplies with the negative 8. So that gives us a negative 40. And then we subtract 1 from the original exponent, which is going to be negative 40x to the fourth. And this is the method that we are going to be using because ultimately what's happening is you're just multiplying the negative 8 and 5. So we skip this middle step and just go straight to the multiplication by multiplying 5 times negative 8. Next, we want to find f prime of x. So remember that if you have f of x plus g of x, we just take the derivative of each of these and we add them. So f prime of x, let's start with the 8x cubed. The 3 multiplies with the 8. That gives us 24. And if I subtract 1 from 3, this gives me 24x to the second power. The 2 multiplies with the negative 4. This gives me negative 8x. 2 minus 1 is 1. So that's negative 8x to the first, or just negative 8x. And the derivative of a constant is equal to 0. So that's it. That's our answer. Let's take one more. G of x is equal to 8 plus 1 over x squared minus 1 over x to the fourth. First of all, we need to remember our rules. We need to rewrite any variable on the denominator. We need to move it to the numerator. So this becomes 8 plus, if this moves to the numerator, it becomes x to the negative second, minus, if this moves to the numerator, it's going to become x to the negative fourth. Now, for g prime of x, the derivative of any constant is equal to 0. For the second one, the negative 2, it's going to come to the front. So that gives us negative 2x, and we subtract 1 from this, which will give us negative 2x to the negative third. Minus. In this case, we have a negative times a negative, so this actually gives us a positive 4. X to the negative 4 minus 1 is negative 5. So this gives us plus 4x to the negative fifth. Let me do that again. The negative 2 comes to the front, so this becomes a negative 2, and we subtract 1 from it, negative 3. The negative 4 comes to the front. Negative 4 times a negative gives you a positive 4. We subtract 1 from it, and gives us a negative 5. We need to rewrite this using only positive exponents, so the 0, we're going to ignore that. We have negative 2 over x to the third plus 4 over x to the fifth. And this will be our derivative. All right, let's do one more, and then I'm going to have you do the next one on your own. So I'm going to rewrite h of x using only rational exponents. So this is going to be 5 over, sorry, this should be x to the 5 over 7 minus 8x to the sixth. And we want to find h prime of x. So the 5 over 7, it's going to come to the front. So we have 5 over 7, and then we take our exponent and subtract 1 from it. The 8x to the sixth, the 6 is going to multiply with the 8, so this gives us negative 8 times 6 is 48. And then we're going to subtract 1 from the exponent. So to simplify this, 5 over 7 minus 1, I'll do this on the side. So if I have 5 over 7, 1 is same as 7 over 7 when you get a common denominator. This gives us a negative 2 sevenths. So this is going to give us 5 over 7, x to the negative 2 over 7, minus 48, x to the fifth. And remember, 6 times 8 is 48, 6 minus 1 is 5. That's how we got this. Lastly, we cannot leave this as a negative exponent. So to rewrite this using only positive exponents, this is going to move to this whole x to the negative 2 over 7. It's going to move to the denominator, become positive. So the denominator already has a 7, and so we're going to get 5 over x to the 2 over 7 minus 48x to the fifth. Okay, and then do the last one in class.